All right, everybody, welcome back. And look at this. It's the same data from section 2.2. Okay, so I've already got it in my calculator. You probably don't, but that's okay. I can live with that. So the number of inmates incarcerated is the same as in the last problem. Super groovy, cool. Once again, year number zero, okay, this time 2005 is year number zero. Wait a minute, wait. Did I get that wrong on the last one? I sure hope I didn't. Give me a second. Okay, no, I'm good. All right, so yeah, in the 2.2 video, we had things just a little different, barely. Okay. Um, it said the year 2000 was year number zero, and on this one, it's going to be the year 2005. So when we go get our quadratic regression line or quadratic model in the calculator, we're going to plug in a 0, a 1, a 2, a 3, a 4, a 5, 6. Okay, because, for example, the year 2011 is 6 years after 2005. Okay, so that's what we'll type into the calculator. So let's see. So blah, blah, blah. Okay, find a regression equation, 3 decimal places. Got it. And it's supposed to be quadratic. Okay, so let's get to it. Now, because the data is all the same, and so we're making very little difference. Our equation is going to be very similar. Okay, let's see. I think I can just go up there and say L1 minus 5. And then there. Okay, and that subtracted 5 from everything. Okay, or you can just type the numbers in. All right, so I've got all my data in there, and I want to get the quadratic regression equation. So I'll go stat over and then down to a quadratic. And again, it's L1 and L2. And so we got this. Cool. Cool. All right, so let's write that down. And I believe it said 3 decimal places. So I'm going to go, yeah, I guess right here. Gets a little long. So y equals negative 5.440 x squared plus 40.893 plus 1452.476. Okay, so there's my regression equation. And I mean, whether you start with year 0 is the year 2000 or year 2005 is year 0, you're still talking about the same data. So that's why the graph looks the same as before. Now, it's labeled differently on the y-axis. That's the only difference. But other than that, the graph is identical to the one we did in the last video. Okay. So I got part A done. Now part B, use your equation to predict the number of prisoners in the year 2016. All right, the year 2016, well, let's see, what year is that? How many years beyond 2005 is that? Oh, that's year number 11. Okay. So, so that's what I want to know. Inquiring minds like mine want to know. So I'm going to go negative 5.44. I don't really have to do the 0 on the calculator. It won't care. Okay, and I'm just plugging it in for x, plugging year 11 in for x because it is a year. And in this problem, the years are the x values. So I plug it in for x. All right, then we go plus 40.893 times year 11. Plus 1452.476. I think I typed that all correctly. All right. So according to this model, we predict that in the year 2016, there'll be 1,244,000 prisoners. So that would be 1,244,000. Okay. But that would be our answer to part B. All right. So that's how we do it. All right. Part C, use your equation to predict the year the U.S. person population will be down to 1,450,000, accurate to one decimal place. So notice on part B, it was here's the year, plug it in, okay, to get the number of prisoners. Or in other words, here's the X value, plug it in to get the Y value. But on part C is the new part. That's the new thing in this section. Part C is, hey, here is the Y value, the number of prisoners, go find the X value. All right, so how do we do it? Well, I'm glad you asked. Okay, so here's how we're gonna do it. There's more than one way to do it, but the way I'm gonna show you is the way that the author shows you, so that tends to work pretty good. So because this is a Y value, I'm gonna plug it in for Y. But before I do, remember, the number of prisoners in this is always in thousands. So, and since 1,000 has 3 zeros, okay, I'm just going to knock off those last 3 digits. Okay, and so 1450 is what I'm going to plug in. All right, so 1450 is my Y value, 1,450,000 prisoners. Okay, so that's step 1. Plug it in for Y when you're solving for X in a quadratic chapter 2 problem. Step 2, you got to get everything on one side. You've probably seen that before sometime in the past. Get everything on one side. So in this case, what that means, where's my colors? Oh, they're down there. So what that means is I'm going to subtract away the number I just plugged in. Whoops. I have to subtract that from both sides. Okay. And then that gives me a 0 on one side. And on the other side, I get all this other wonderful stuff. Bless you. Okay. Let's see. If I subtract that, I'm going to get 2.476. Okay, cool. So now here's the deal. Now we got to use what's called the quadratic formula. If you've done it before, great. Okay. Once you have a 0 over here, then we have to say, well, the number multiplied by x squared, that's called a. So a is negative 5.440. Okay, not negative 5.440 x squared, just the number. B is 40.893, and C is 2.476. C is not 1452.476. Okay, you don't determine what A, B, and C are until you have the 0 over here. All right, so now we're ready to plug this equation into the quadratic formula, and that will solve for x. Okay, in other words, in this case, the year. All righty. So the quadratic formula is, and I'll even sing you the song, okay, because everybody loves it. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Wasn't that wonderful? Okay, so that's the quadratic formula, and the author goes through it, and it's super, super common in algebra classes to discuss it, so you can find additional stuff about it on Google and YouTube if you want. All right, so let's plug that into the calculator, okay? Let's see, I don't really need that stuff. Okay, so I'm gonna make a big fraction, and then I'm gonna type it all in. Okay, so it says, first thing, do the negative sign. Got it. Then it says do the B. Okay, B was 40.893. Is that my dog? Hey, Zoe, you up here? I guess not. Okay, 40.893. Okay, then it says you're supposed to do the plus and minus. Well, the calculator won't do both, so you just do one of them at a time. So I'll do the plus sign first, and then I'll come back and get the minus in a minute. Then it says do a big square root sign. So I'll go second square root. Then it says do B again. Well, B is 40.893. Yeah, B is very popular. Then it says we got to square that. Square the B. So I'll square it. Then it says a subtraction sign. Then it says do a 4, and we're going to multiply that by a. Now a has a negative, so I'm going to put it in parentheses just to make sure that it doesn't freak out on me. 5.44. Okay, and then it says multiply that by c. I can put it in parentheses if I want. I don't have to. It's not negative. Then it's okay. So we're all done with everything on top. Now we got to go down to the bottom. So I'm going to hit the down arrow. And I'm going to do a 2, and then I'm going to multiply that by a. So negative 5.44. All right. Boom. So we got that. So, but we got to do the negative one also. So we, in that plus or minus, I did the plus, now I got to do the minus. So I'm going to arrow up to all my work, hit enter, and then I'll use the arrows to navigate to that plus sign right in front of the square root, and then I'll turn it into a minus. Enter, done, got it. Wasn't that cool? Yeah, we're not typing it twice. No, thank you. Okay, so let me do a little bit of erasing here. So this is a little easier to see what we're doing. Okay, so we got that. Get rid of that too. And all right. We got 2 answers. Well, that makes sense because we were saying, hang on, let me go back to the graph. Easier to see what I'm talking. Because in this problem, part C, it said, hey, use your equation to predict which year the population will be 1450. Okay. Well, 1450 is, let me get a straight line here. Right there. 1450 is going to be right about there. Okay, that's where 1450 is. Well, guess what? The equation is going to hit it right there, just to the left of the x-axis, and then it's going to go up, and it's going to come down, and it's going to hit it again somewhere. Okay, probably not there, but it's going to hit it in 2 places. All right, so that's why we got 2 answers. It makes sense. So so the first answer, let me turn that little schlangy dang off. The first answer was negative 0.06. So that would be the year negative 0.06. So just about year 0. Well, on this problem, year 0 is the year 2005. So this is going to be like just before 2005. So maybe like December 2004 or something. Okay. But let's look at the wording of part C. It says, use your equation to predict the year the prison population will be down to 1450. Because they only want a single year. Well, when will it be down to that? Well, that'll be down over here when it's coming down, when the function is coming down. Not over here, but over here where the function is coming down. So that'll be our second answer, which would be the year 7.6. So about halfway through year number 7. So year number 7 is going to be the year 2012. Okay, but it says to 1 decimal place. So you would just say 7.6, or you would say year number 7.6 for part C. Then it says, hey, go find both years. Oh, okay. So, okay, go do both of them for 1400. Accurate to 1 decimal place. Okay, so I'll let you take care of that. But the only difference that you're going to do on this one compared to part C is whoop, you're going to have a 1400 right here. That's going to be the only difference. You're going to subtract 1400 from both sides. Okay. And then that'll be it. And then everything else you do identically to what I just did on part C. Okay. Anyway, that's and that should help you out. And don't forget to look at the examples that the author has too.